Today I wanted to discuss an example involving power of a power. So in this case, we have a few examples. So we're going to be covering one example where basically the premise of it is you have a few terms or maybe one term inside a bracket with an exponent on the outside of it. And I'm going to show you exactly how to deal with a question like this. Don't think of this as, well, this is just to be clear, this is just another rule involving exponents, as was this one in the previous video where I covered multiplying and dividing exponents or terms with exponents. This example involved the addition in the case of multiplication, as you see. So x squared times x squared. Since these were the same two terms, all you have to do is add up the exponents, and you come up with x to the power 4 as a simplified version. But when it comes to this example and examples similar to it, what you're going to do is you're going to use this and you're going to have to distribute it within the bracket. And I'll show you exactly how to do that with this first example here. So you want to go ahead and first of all rewrite your example here. 2x squared times y to the power of 3. Everything within the bracket with the exponent of 3 on the outside. And then on the bottom you have 2xy squared to the power of 2 for everything within the bracket. So how you do this exponent is actually not on a term as it was in this where the exponents were only on terms. First of all, what you have to do is you have to put this exponent on each of these three terms, and you want to cover them with the brackets. So basically, since we have three different terms here, we want to first take one extra step before we basically use the rule that I was talking about. So we have 2 to the power of 3. So you're distributing it. So this goes over here. This one goes here. This one goes there. So you're going to have x squared to the power of 3. And then you're going to have y cubed to the power of 3, right? And the same goes for the bottom. So you're going to have 2 squared times x squared. Since obviously there's a 1 here, it's x to the power of 1. 1 times 2 is 2. So you have x squared. And you have y squared to the power of 2, right? So that's the first step you want to take. You want to make sure each of these terms have the exponent applied to it. And the next step you're going to take is you're going to apply the principle of power of a power. So 2 cubed, that's just going to be 8. 2 times 2 times 2, that's going to be 8. That's not applying the rule. In this case, you'd be applying the rule. For this x squared, this y cubed, and this y squared, you're going to be applying the power of a power rule. So how you do that is you're just going to multiply the exponents, right? You're going to multiply these exponents in this case. So 2 times 3. So you're going to have 8 x to the power of 6, and then you're going to have y cubed. So you're going to multiply 3 by 3, so you're going to have 9. So you have y to the power of 9, right? And then on the bottom you have 2 squared, which is 2 times 2, and that's going to equal to 4. And then you're going to have x squared, that's nothing changes there. And this one is going to be, so it's y squared bracket to the power of 2. So you're going to multiply these exponents. So you're going to be left with y to the power of 4. You could simplify this further now. As you see, we have two numbers in front of these. And then you have, you have two, I guess, decimals, which are numbers. So you could actually divide these. And then you have two of the same terms here. So you have x at the top and bottom, you have y at the top and the bottom. So now we're going to apply the previous rules we learned in the previous video, which is multiplication and division of powers. As you can see, there's no x, there's only one x term at the top, one x term at the bottom, and then same for y. So we're just going to be applying the division of power rules, and as opposed to this where you add up the exponents, we're going to subtract, as we said. So 8 divided by 4, you're going to have 2 at the top, and then you're going to have x to the power of 6 minus 2, and then you're going to be left with y to the power of 9 minus 4, right? Boom. So your end result for the first problem is going to be 2 times x to the power of 4 times y to the power of 5. And that's your result for the first answer, or the first question. Now we're going to go ahead and do the second one. Alright, so we have, as you see, we have 5 squared times 6 to the power of 6. And then at the bottom we have 5 to the power of 1. But because it's, when you have a 1, you don't have to actually write that, because you're not multiplying 5 by itself. It's just literally 5. 5 to the power of 1 is 5. Right? So you don't have to actually write it. The only time you have to write it is if there's more, if there's 2 or 3 or 4, anything above. But if there's an exponent of 1, that's unnecessary. Every single number has the exponent of 1. Well, it could have it. In essence, it's but it's unnecessary to have. So I'm just going to write 5 to the power of 4. And then we have 6 squared to the power of 3, right? So now we're going to apply this rule to every single one of these 4 terms. So what's going to happen is we're going to have, actually on the top, we're just going to leave it the same because there's no exponents to multiply by. So we're just going to have 5 squared, 6 to the power of 6, and then we're going to have 5 to the power of 1 times the exponent of 4. So it's going to be 1 times 4 there, which is 4, right? 5 to the power of 4. And then we're going to have 6 squared to the power of 3. So that's just going to be 3 times 2, as we said. So it's going to be 6 to the power of 6, right? And now we can actually apply the division of power rule. So what's going to happen is we're just going to do basically, because 5 and 5, these are the same terms. You could put all this in the calculator, but you could actually simplify it before you even put it in the calculator, right? Depending on whether or not you're even allowed to use one. But you could simplify this quite easily. Just imagine there's an x here, or an x here, and then a y there and a y there. It's pretty much the same thing, except you're just using a 5 and a 6 instead, right? So you have 5 to the power of 2 and 5 to the power of 4 at the bottom, right? So you're going to you always subtract the exponent at the top minus the exponent at the bottom for the same terms, right? So it's going to be 5 to the power of 2 minus 4. Okay? Now you're going to multiply that by 6 to the power of 6 minus 6. Alright, and what is this equal to? 0. So any number or any term, it could be x, it could be a y, anything to the power of 0 is going to be equal to 1. This thing is going to be equal to 1. So it's a non-factor. It's not going to affect anything. right? So you're going to be left with this part of the equation there. So it's going to be 5 to the power of negative 2. 2 minus 4 is negative 2. And what does that, as we mentioned in one of the previous videos, what happens in this case? Well, simply put, you're just going to basically flip this number to make this a positive. So you're going to put the 5 at the bottom, and the imaginary 1 at the bottom, you're going to move it to the top, and you're going to leave that exponent on the 5. So now it's going to be a positive. So this is equivalent to this. 5 to the power of negative 2 is equivalent to 1 over 5 to the power of 2. So you're basically just flipping the number, and this becomes positive. So that's the end result for number 2. Obviously that's number 1. Those are the end results there. And now we're going to cover the last problem. Okay. Alright, so we're going to use the same exact rule, exponent rule here. Well, rules, because we're going to be using both. So we have 2 squared. Hold on, let me just rewrite that. That is very messy. Still getting better at this. So, okay, so we have 2 to the power of 4 squared, and that's going to be to the power of 3. Okay, and at the bottom we have 2 squared to the power of 3, and that's going to be squared. Okay, so in the case of power of a power, you always want to start from the outside. You want to start from the furthest power. So what do you do in this case? Well, in the end, you're still going to be multiplying the same numbers, but just to make it clear for yourself, you want to start from the outside and move inward. So as we said, power of a power, right? So it's going to be, this can be multiplied by that, right? Both of these don't have a term. But since this is a bracket here and this is, it's on the outside of this bracket, this 3 can be multiplied by that 2. So what's going to happen is you're going to have 2 to the power of 4, right? And then that's going to be to the power of 6. That's the first step. That's the first, simplification there. So it's going to be 2 to the power of 2, and then again to the power of 6 because it's 3 times 2 there. Okay, so now we're going to do the rule one more time. So it's going to be 2 to the power of 4 times 6. That's going to be 24. And then the bottom is going to be 2 to the power of 2 times 6, which is 12. Now we're simply going to use the division of powers rule. As we said, it's when you have the same terms, you're just going to subtract the exponent. So it's going to be 2 to the power of 24 minus 12. 24 minus 12 is just 12. So you're going to have 2 to the power of 12. And that's going to be your final answer for this problem. Hope you guys enjoyed this video. If you have any questions, please let me know below and I can make another video, or I can maybe even respond to you in a comment.